Hello, friends. It's been more than a minute, but we are happy to be back with episode 144 of the Our Weekly Highlights podcast. We did have a little bit of an extended break due to various issues, and plus, here in the U.S., we had the Thanksgiving holiday. So I just heard that it wasn't just me; it was a few other podcasts that took the week off to have some nice time with friends and family. But nonetheless, we are back. My name is Eric Nance, and I'm so delighted that you've joined us from wherever you are around the world listening. And keeping me sane and keeping me on my toes is my awesome co-host, Mike Thomas. Mike, how are you doing today?
Doing well, Eric. I hope everyone out there that celebrates had a nice Thanksgiving, and it was nice to have that week off. I know we've been a little back and forth here with, I think, some pharma conferences, right, as well as the Thanksgiving holiday. So hopefully we can finish up the year strong and look towards 2024. But excited to be back on the mic for this week's edition of Our Weekly.
Yes, it always doesn't feel right when we don't get together once a week. So yes, it's great to have some normalcy again. But speaking of normalcy, as if you're unfamiliar with Our Weekly, this is the effort where members of the R community have bootstrapped some of the best resources that we see every single week. And our curator for this week is Tony Elharbar, another longtime contributor to the Our Weekly project. And he had tremendous help from our fellow Our Weekly team members and contributors like you all around the world with your pull requests and other great recommendations to us. So let's dive right into it. One of the kind of learning goals I have for certainly next year, although I did some of it this year, was taking more advantage of object-oriented programming in some of my larger scale R and Shiny development adventures. And in our first highlight here, we have a great accessible kind of tutorial for how that really looks in a real world type situation. This comes to us from, they go by Numbers Around Us on Medium. I was not able to track down who they actually are. So whoever you are, well, there you have it, I guess. But they have a great post here called Object Oriented Express, Refactoring in R. And the first part of the post is a nice little gentle introduction to just what might be the best benefits for this at a high level. But then they dive into a specific example where they have, imagine a set of R functions that are helping produce a report on data quality. And if you take a functional approach, you might have one or more functions that are tailored to maybe specific steps of that workflow. Maybe with importing and cleaning data, maybe to prepare the data for like a visualization or a summary report, other functions that actually generate the report. And as you can imagine, maybe for a smaller scale effort, that can scale pretty well. But if you have a lot of different things you want to do with that type of workflow, it could get a little unwieldy to do so many functions at once. So that's where they talk about, well, let's imagine if you define this as an R6 class. For those that aren't aware, R6 has been around for quite a few years as a different take on object-oriented structures in R that's kind of trying to be a good blend between what we would see in things like S4 and also the other object-oriented class structures in R. And for the Shiny fans out there, R6 is a huge part of the foundation of Shiny itself, which is one of the reasons it has my attention quite a bit to up my skills with. But back to the blog post. So the example code that the author shares here is a set where he set up some simple data set, a simple tibble of various parameters, 1,000 records of different categories, typical numeric values, a date, and some random text associated with it. And then what does making an R6 class actually look like? Well, I won't read it verbatim, but appropriate enough, you define an R6 class. And inside it, you have a few different things. You have this public slot, which is a list of the different either data-like structures that you want or parameters you want that the user is going to specify themselves, and then functions that take that initial specification and do something with it, such as actually initializing the object itself. And in this case, there's a data frame that the user is expected to put in, but then you can build in error checking because all these different functions are just R functions. You're just encapsulating them in this R6 class. So you can have functions like in this example of deriving how many missing values there are. And guess what? The code inside that function is a very familiar tidyverse pipeline. So there's nothing that mysterious about what you can put into an R6 method that goes with this class. So really the possibilities are practically endless, but it goes with another function for detecting outliers, summarizing data types, and then actually getting to that generation of the report, which ends up being a list of the different sub-methods that are inside it. Once you have that in place, and if you want to actually use it, you're just going to instantiate a new object, and that's literally with the $new after the class name. But this is very much the same paradigm that is at the nuts and bolts of many of the underpinnings of Shiny itself, even some of the extension Shiny packages like Shiny Test 2, which also has its own object-oriented approach to define its testing mechanism. Once you have that in place, then if you want to generate that report, you're going to reference that class you just made, the object representing that class, and just call $generate report. It's like calling a function, but in the confines of the class that you just generated. Now, you may be thinking, if the post ended there, well, what's really in it for me, so to speak? That's where the last half of the post talks about what are the improvements you gain from this if you stick with this approach. The author states that you have improved readability, enhanced maintainability, and easier ways to debug and test, and also being able to reuse this quite a bit. I'm going to be kind of transparent here. The example may not quite do all of those justice here just because it is a small scale example. You really see this, I think, when you have a more complicated structure with many different potential methods, many different types of data inside it. And we've actually seen in previous presentations, I'll call out a presentation at the Shiny conference that was run by Absalon earlier this year about how R6 can be used as a good state management mechanism for your Shiny app state when you pass things back and forth between modules. So I admit this example may not fully articulate everything of these benefits, but the post does show about what if you think of a new method that you want to impose on this class. If you make the class extensible, you can have you as the user extend that with a new function right away and call it with the $set directive and determine if that's a public method or a private method. But then you can define that custom function right then and there. And then when you instantiate a new version of that object from that class, you can reference that new function right away. Now, that may not be the way you want to extend it in an actual R package, but in an interactive approach, I think that could be quite handy. R6 definitely has a lot of intricate parts to it. I'm not going to lie, because I've been trying to learn it for earlier this year. I've gotten kind of far. I had a little help along the way from a very important person to help me along the way. If they're listening, thank you, Joe. But it's been quite a journey to get there. But I think for my larger scale Shiny app development and some more of my complicated R packages, I don't think I can take the functional approach everywhere I want to go without some kind of class management along with it. As you can tell by my voice, I'm still kind of new to this, so I'm still kind of learning along the fly, but I do think this post is a good little snapshot of what is indeed possible with R6. So Mike, I don't know, what's your take on using R6 these days?
Yeah, I think there's a lot of different reasons why you might do so. Probably one of the first times that I encountered, R6 sort of right in front of me was the waiter package within Shiny, where you can create a waiter object using that $new syntax. And then you can leverage that different places within your code. And in the Engineering Shiny book from Colin Fay, there's a section that talks about how to pass data or objects between modules, right? There's a lot of different ways to do that. But one of those ways is to take an object-oriented approach as well. So that's something that's maybe not mentioned specifically in this blog post, because this blog post isn't geared specifically towards the Shiny crowd, but that is a potential use case for wanting to do some object-oriented programming to make your life a little bit easier within a Shiny setting. I think one, really powerful other example that I can think of when it comes to object-oriented programming, and it's something that we've been doing a lot at Catchbrook lately in some of our R package, that R package development around predictive modeling, is I think folks take for granted how you can use the same function, essentially like predict, for instance, against a bunch of different classes of models. It could be a logistic regression model, it could be a linear model, it could be a XGBoost model or a survival model. They all have methods built into them within those respective modeling packages to predict, a predict method against the model object. And those predict methods work different ways depending on the object that's being called. So it's really interesting. It's really powerful. And the fact that you can also sort of pretty easily extend on top of these objects, as is showcased in the blog post here, I think makes a great use case for it. It's always going to be a trade-off, in my opinion, as to whether taking the object-oriented approach is overkill for your use case, where it would make sense to just create sort of a simple, pure R function, or whether your use case has the complexity within it to sort of justify leveraging an object-oriented approach, where it makes more sense to do that than trying to handle all sorts of different edge cases within just your pure R function. Sometimes handling those different edge cases can be a lot easier, a lot more clear to articulate when you're taking an object-oriented approach, whether that be R6, S3, S4, S7. I guess at this point, most of my experience, just to be honest, has only really been within S3. I need to start, like you, Eric, reaching out beyond that into R6 and I guess S7 these days as well. But this was a really great walkthrough. I don't see a ton of blog posts that really take sort of a smaller use case like the author did here into getting you up and running with R6. If you look into any of your favorite R packages that are out there, if you actually dig into the source code, when I first started looking at source code for some of my favorite R packages, specifically in the Tidy Models ecosystem, almost all of it is object oriented. All the workhorse functionality that you're trying to understand what's going on is all that code is written in an object oriented approach. So if you're not used to that syntax, it can be a little daunting to read and to try to figure out what's going on. It's try to understand, how the logic works and where things are placed and how things relate to each other. So my advice, even if you're not necessarily going to be using object-oriented programming within the code that you write, I would at least try to gain some understanding of some of these object-oriented approaches. Maybe just start with S3, because I think it's probably the simplest, right, object-oriented approach within R, and understand sort of the different components to creating objects within S3, such that when it does come time for you to maybe understand what's going on under the hood of some of these functions that you're leveraging from other packages, you can take a look at the source code and understand what's going on. So I think a lot of different use cases, potential use cases for object-oriented programming. I think a lot of folks, probably like me, who started out more as statisticians and got into the world of programming after the fact, may not be super familiar yet with object-oriented programming. But I think there's no time like the present, right, to get yourself up to speed and maybe make this your next sort of learning adventure in the R world.
Yeah, I echo all those same points, and I'm also, as you mentioned earlier, keeping an eye on S7 as well as another very promising, new approach to the S3-like syntax, but also bringing in some principles that S4 brought to the table too, albeit in a lot more complicated way. And we have previous highlights that address S7 as well, so definitely keep an eye on that space. I even, it was about a month or so ago, sent out a toot on Mastodon to our good friend John Harmon, because he's been pushing the paces of S7 through some of his package development, and I just threw out there, oh yeah, maybe S7 might be good for Shiny. He's like, well, maybe not, but R6 is still the way to go there. And I was doing a quick scan as you were talking, Mike, the CRAN page for R6, and you look at the reverse imports section. There are a lot of R packages that import R6. I'm looking probably almost 100 here, it looks like. So it has definitely got a lot of attention in the package ecosystem, and it looks like a very decent chunk of them have Shiny involved one way or another. So interesting time if you're in that space to really dive into R6 further. You heard me mention dependencies, Mike, about what R6 and what packages import R6. Well, that can be a big decision if you as a package author of, you know what, I could code this up all myself using base R functions, but is there another package that really does what I need for my particular package as a dependency I should investigate? That can be a big decision sometimes. And what can factor into that decision? Well, that's where our next highlight comes into play, because you could actually do some interesting benchmarking to guide you on that decision process of that new package you're creating. Should it take that additional dependency or not? This blog post comes from the Epiverse blog, which has been featured in previous highlights, and in particular from James Azam, who is a research software engineer, who starts with a pretty simple example, but yet I think is quite powerful. We're talking about you as a package developer. Maybe you want to look at different ways that you could signal to your package user when things go wrong, or maybe areas that they should watch out for. In base R, this has been supported for, since R itself, with what's called conditional signaling. You're communicating to the user when an issue has arisen. And if you're familiar with the R language itself, which hopefully you are, you might have seen these type of dialogues where one is just a message, another is a warning where, it's not quite enough to stop everything, but it's enough you should keep an eye on. And then you get errors where everything comes to a screeching halt. So usually it's one of the three. And you can certainly base your package development on using those, those conditional signaling quite easily. Now, there are some interesting packages that kind of give you enhanced versions of that. One in particular that I've been starting to use a bit more in my internal development is CLI. This is a very handy package, which you probably have seen without realizing it. If you use frameworks like DevTools, use this, and many others, Golem itself leverages this. You will get these very nice formatted messages in your console that don't look like just plain text. You get these nice divider lines, some syntax highlighting, color coding, and even those fun Unicode symbols along the way too. It helps the presentation of it. But there's other things that CLI offers in that, such as its own version of stopping for an error. They call it the CLI abort function. And so you can use that in your package as an alternative to the stop function from base R. So yeah, that's a great choice, right? But when you make that choice, what is the cost, so to speak? I'm not talking about money cost. Everything in R is free. I'm talking about cost and potentially execution time or maybe other factors. And so the rest of the post here talks about maybe looking at some different scenarios where you want to do your own version of a warning function, but maybe another alternative is using the CLI package's version of the warning function, and seeing what the trade-offs are and actually benchmarking that performance using the bench package, which has a function called mark, where you can also wrap this in a function called press. And as somebody who's been lifting weights for a while, I love that package name. I just love it. So I don't know if it was Jim Hester, the author bench, but it's a great package. Absolutely love it.
Yes. It is clever too with the function arguments.
Yep. So the rest of the post talks about, what are the different trade-offs in this from an execution standpoint. So I guess not so much spoiler if you read the post, but there is a slight more execution time needed for the CLI package. But this is not unheard of, right? It's doing a few other things under the hood on top of what just base R does with its stop or warning functions. But you have to think to yourself, is this really practically going to be a hindrance to my package I'm creating? yes, it may be consistently slower than base R, but at the same time, the benefits you get from CLI may be more than worth it. So context is key here, as the author points out. And this is also touched on in the R Packages book by Hadley Wickham and Jenny Bryan, that you want to look at multiple factors in this decision. And you don't want to fall into the trap of what they call optimization overkill, because we can try to make things as blazing fast as possible, but it could be at a cost of like development time and extensibility, to the future life of your package. So this is just one approach to see what the cost might be from an execution standpoint. But I would also mention there's another thing to factor into this, is that there can be an interesting kind of web we weave, so to speak, of a package depending on another package, depending on another package, and you're kind of opting into that contract of dependency every time you add another package to your imports field of what you're creating. So this post doesn't so much touch that as much, but I'm going to put in the show notes here a link to another package that might help you analyze some of that, called Package Depends, which you may have talked about in recent highlights, where you can get a nice view of, for a given package like CLI, what packages that depends on, what packages those dependencies depend on. So you can kind of get to see what that dependency tree might look like. So that might be another factor into your decision. But nonetheless, I really like this approach of, you know what, if you're not sure, run some benchmarks and see what that opportunity of adopting this dependency might, quote unquote, cost you, or you might get some significant gains along the way too. But keep in mind, it's not just one factor. It is multiple factors. Execution time is what we often hear about, memory management, but it's also if the package itself has a really elegant API, so to speak, and how to use its base functionality. Heck, I want to make my dev life easier. I'm going to opt into it. That's why when people ask me in like various workshops that I've done with Shiny, how much is too much from the dependency footprint? Well, I'm not going to be that guy to always say it depends, but at the same time, really, what are you most comfortable with? I have no issue depending on things like you mentioned, like Waiter package or other things that are giving me enhanced functionality that I technically could do myself if I knew enough CSS and JavaScript custom to do it. But why? If John Kuhn has solved it for me and there's not much of a performance hit, yeah, I could benchmark it, but I feel like you should take it on a case-by-case basis. But I'm not scared of my apps depending on other packages, as long as I'm clearly, knowing myself of what I'm getting into. But luckily, when you do that exhaustive look at a package, I think you can make an informed decision. So I think this great post here is another example that James has put together of ways you can help make that decision in an informed way.
No, I couldn't agree more. And it's interesting, taking sort of a quantitative approach to deciding whether or not you're going to leverage, a non-base R function and import a package. And the author, James, says that he quotes the R Packages book by Hadley Wickham and Jenny Bryan, who suggests that approaching this type of decision should be done from a holistic, balanced, and quantitative approach. So that's I don't know. I think I found that pretty interesting and something that maybe I haven't thought about enough when considering, which way to go about solving a problem within R. I guess I will also sort of articulate before I even further comment on the article, the CLI package is awesome. It's awesome. If you are building R packages that other people are going to use, and you want to make them very user-friendly, that means informative error messages, informative warnings, informative non-error messages. And CLI allows you to return some of those messages in the console in a way that's almost like writing Markdown, right? You can have bullet points, you can have line breaks, you can have all sorts of things that are really clean and look really nice in the console, and sort of, in my opinion, make your package a whole lot more user-friendly than if you were trying to use, base warning, message, stop type of functions. So That's all to say that I love CLI. I can't imagine that, maybe warnings would be potentially one case where you could have a function that could return all sorts of warnings. I'm thinking about the reader package when you're reading in a CSV or something like that, and it's coercing an entire column to null because the dates aren't formatted right or something like that. Not that I'm speaking from any sort of experience with that targeted example, but and it shows like use warnings to show there were 50 or more warnings or something like that, right? But most of the time, I feel like your error messages and your warnings and your messages and things like that are really triggered by sort of a single if statement, and performance. It's not like you're crunching through a bunch of data, right? It's not like you're doing large data summarizations or something that's really computationally intensive. Most of the time, it's just solving an if statement, which shouldn't be too much overhead. So your performance changing from 1 millisecond to 10 milliseconds in a lot of the examples that they're showing here between base and CLI, in my opinion, is worth taking that performance degradation to provide a better user experience. But obviously, it's all based upon use case, right? Your use case may not be comparing CLI and base. It might be comparing reading CSVs. It might be comparing doing some sort of data transformation in dplyr versus base R, and taking a look at what the differences are there. So I have a lot of team members who I think probably get mad at me when they want to utilize a package for one function in an analysis or in an R package that we're developing. And it sort of pains me to import an entire package just for one small function. So a lot of the times we'll try to see if there's a way to, more easily or not without much more difficulty, recreate the logic using a package that we've already imported or base R to try to accomplish that same thing. But obviously, it's just a large game of trade-offs that you have to make when you are doing any R package development or just any sort of analysis and R work that you're doing. But I think this is a really cool approach to helping make those decisions. So I really appreciate this blog post.
Yeah, that does remind me of some conversations I've had literally this week as we're thinking about, ways of, newer users of R at our organization, getting them up and started on the right foot with like a clinical analysis. And that's where maybe building an internal package as kind of like a way to wrap new project templates in something like Posit Workbench, where they can quickly create this new project. And then as they're creating it, it's not just creating the files, right? It's also what's their next steps, right? I mean, and having CLI as a way to, like you said, have this nicely formatted kind of, hey, congratulations, you created this project. Now here's some things you can do next, or here's some resources to check out. That user experience is massive, especially when you get to somebody using your tool or package for the first time. And again, we'll never have a chance not to plug Golem whenever you and I get together, but Golem did a terrific job of having these messages in a use this like fashion about next steps and new ideas that you can do with your application after using some of their utility functions. So yeah, big CLI fan here as well, but also the user experience, whether it's a lower level art package you're creating or if it's a very sophisticated part of the bigger pipeline, is critically important, even at the expense of perhaps a few milliseconds, because it is a multifaceted decision one way or another.
It's all about trade-offs.
All about trade-offs. Yes, indeed. Speaking of performance, there's another language that starts with R that has gotten a lot of attention lately in many sectors of the tech sphere, and that is, of course, Rust. Our last highlight today comes from Josiah Perry, who has most definitely been putting Rust through the paces in his development efforts recently, with an awesome blog post, very much a get you up and running quickly type fashion of building an efficient CSV reader that is built on the DataFusion Rust library, but doing this within R and a friendly little set of bridges between R and Rust. we're going to try to make sense of this. This is new to both Mike and I, so bear with us here. But I think I'm getting the gist of it. So here I go, so to speak. So if you're familiar with packages such as dplyr and others and data.table, you know that they are very heavy users of C++ in their package source code to get efficiency and performance gains, right? And there is, of course, the RCPP package in R that lets you bridge that gap between referencing C++ code and libraries into an R package. Well, Rust has this similar framework here, and this post that Josiah put together talks about using those in action. It's using a package called Extender. This was new to me, but it apparently has even more than one in this space of that way to translate R objects, R functions, and send them back and forth with Rust. So I've never played with it myself, but it does seem somewhat analogous to what RCPP does in the C++ space. So they're actually using both Extender and arrow.extender because apparently this DataFusion library in Rust is going to take advantage of arrow along the way too for a more efficient way of importing large CSV files. So how does this actually work in practice? That's where the rest of the post goes. First, just like with any R package, you can bootstrap this very easily with the use this package, another one that is in Michael and I's wheelhouse every time we create new packages. Once you have that going, then you can start adding your Rust dependencies. This is where it gets into some interesting tidbits here, where in a package like this that you're going to depend on either Rust or C++ or another language, you often have a source SRC directory, and that's where this other language's source code actually goes in. So once they create a directory called src/rust, Josiah actually opens this up in VS Code itself to configure with Rust itself to add the Rust dependencies to this package, and there are 3 of them here. This DataFusion library, which again is bringing arrow data frame objects to Rust. He says it's like polars, but a little different. I've never looked at both yet, so maybe that's on my to-do list next year. Another one called Tokio, Tokio, which helps you do asynchronous code processing in Rust. And then arrow extender, which is a package that Josiah created himself that helps send arrow data from Rust to R and back. So again, that translation layer between the 2 languages. So he's got some terminal code using the cargo utility, which is kind of like Rust's package manager, I guess is the best way to say it. Little snippets to get those dependencies bootstrapped, and then start tying in how R will talk to these Rust dependencies. And apparently there's a C library that's also needed for the DataFusion side. So we're mixing both Rust and C here. So yeah, buckle up. It gets pretty interesting here. But the rest of the post starts talking about, okay, what does the Rust code look like to start extending, the functionality from these libraries and then returning results to the R side of it. So again, not a Rust expert here, but there's some very small snippets here leveraging the read CSV functions from this DataFusion package, and then exposing that as a module, I believe, in the source code, and then starting to import additional dependencies and adding some more code around the functions themselves. Again, not something I'm in my wheelhouse with here, but it kind of builds step by step. You get the basic reader, start to augment the asynchronous operations inside of it. That's more dependency, declarations, more variable declarations. And Rust, what I've learned in my short time with it, you have to be very explicit when you create new variables, create new objects. It has very tight kind of syntax checking, and to let it'll basically stop in its tracks if you're not explicit about data types and what they happen to be. So you do have to define your scope pretty carefully. But then the post continues on with more updates to these functions and what it's going to be returning, and returning the type of R object so that R can interface with this as if it was a typical, data frame like syntax. So there's a lot to digest here, but once you compile all this, again, somewhat similar to what you do in RCPP, if you were building an R package based on C++, you then can create your package that has a friendly wrapper function, read_CSV_defusion, and then it'll look as if it operated just like a read.csv function in R, but behind the scenes, it's not R doing the heavy lifting, it is Rust. So I hope is that this is just the start of, tutorials in this space of creating these Rust-based packages, because we are seeing a lot more popularity from those that are trying to eke out even more performance of Rust being an alternative to the traditional C++ paradigms that we've been seeing it for many years in the R community. So thank you to Josiah for putting this together. I'm going to admit I probably didn't do any of that justice, but this is a great kind of hello world type setup with a practical use case for you to practice along at home if you're starting to get into Rust for the first time yourself.
Yeah, this is pretty incredible. And I guess this week's version of the highlights seems very R package-y centric. So I don't know if that's on purpose or not by Tony, but we'll have to ask him himself to get his question. So this was my first foray into the Apache Arrow DataFusion package, which was really interesting, and it's defined on the Apache website as a very fast, extensible query engine for building high-quality, data-centric systems in Rust using the Apache Arrow in-memory format. So I guess that's what Josiah is leveraging pretty heavily here. It's what he's leveraged as well to create that package that he developed himself called Arrow Extender, which I believe is a Rust library that you can find in his GitHub. And one thing that was interesting to me, after he first sort of creates the R package using use this create package, the next thing that he does is use a function from the R Extender R package called use_extendr. And what that does is it really scaffolds out sort of everything that you need within your R package to leverage Rust in concert with your R package. So I think there are some similar functions for kind of scaffolding an R package for leveraging C++ and C and things like that. So I think this is sort of a synonymous function when you were trying to use Rust code within your R package. So it's nice that we have that utility function to be able to use to sort of set everything up nicely for us. Again, this is probably one of my first times taking a look at Rust code. It's interesting because I think some of the things that we've talked about earlier on in this episode are coming full circle a little bit. I definitely see some what looks like object-oriented programming going on. A lot of variables that are getting instantiated are sort of suffixed with this new parentheses call to them, which to me looks a lot like some of the R6 stuff that was going on previously. One of the things I like about Rust as compared to Python, I've been writing quite a bit of Python code lately as well, is that it looks like you can specify arguments on new lines. So white space is not a huge deal within Rust, which is nice, as opposed to, white space and tab space and things like that are very upsetting to Python potentially. So it's a syntactically nice to look at language, which I certainly appreciate. We're also talking about methods and things like that, and it's nice to see that there is a nano arrow R package as well, which I think is what Josiah uses to be able to sort of stream some of this data between Rust and R. But he also mentions that if you just want to get everything at one time, there's a handy as data frame method already available for these nano arrow array stream objects, which are these objects that get returned from the result of Josiah's read underscore CSV underscore defusion call within his package, where he's, I believe, reading a CSV of the Palmer Penguins package. And the benchmarking that he employs here, again, we're seeing the bench package, pretty cool, is showing essentially that using readr to just read in the CSV data of the Palmer Penguins data set takes about 14 milliseconds, and his DataFusion approach takes under 1 millisecond, like 900.
Wow.
Yeah. So it's a pretty significant performance improvement. Obviously, I can imagine as the data gets much larger than the Palmer Penguins CSV data set, that would only sort of continue to become an exponential relationship. So I definitely see a lot of interesting promise for the combination of Rust and R. It's hard to keep up with like all of these new breakthrough developments and different tools playing with each other to just accomplish sort of more and more and more. But I think Rust continues to be one of those that is pushing the boundaries of what we're able to do in data science. And I really only see that sort of increasing and seeing more developments come out of the Rust ecosystem. So it's nice to see that we already have quite a bit of infrastructure around using Rust from within R. And I think for folks who are interested in using Rust in their R package, I have not seen a better resource than what Josiah has put together in this blog post.
Yeah, it's been great that he's been sharing his learning along the way, and he's been involved in this space, it looks like, for quite a bit here. So I've been following his toots on Mastodon every time he broadcasts a new Rust aha moment or binding to Rust. I'm definitely paying attention. Boy, between this and what we're doing with WebAssembly in R, with WebR, and my Java, I don't have enough brains to keep it all together. I was one of the off nights under this break, I was rewatching one of the Matrix movies, and boy, I wish I had that thing just plug in the back of my head, get all this in 1 second, and then I become this ninja of a programmer across all these languages. We're not there yet, folks, but maybe someday. But our weekly can help you get there a little bit of way there, at least.
I think they call it a module too, right? When Neo goes to learn how to fight
exactly.
Morpheus. Yeah.
Yes.
Oh my goodness.
Modules. Who would have thought, right? Yep. But you know what you can think, though, is that just like Josiah's post here and all these different themes that we touched on today, our weekly, every single week, has so much content to cover across all the spectrum of data science, software development in the R ecosystem, and certainly linkages to other languages, as we talked about today. So we'll take a couple of minutes here to talk about our additional finds for this particular issue. And I'm going to first give a huge congratulations to the team at Absalon for their initial CRAN release of the Reactable.extras package. If you heard me before on this show and even in my workshops, I am a huge fan of Reactable. It has become my go-to for streamlined, efficient, and frankly, really slick-looking tabular presentations in my Shiny apps and in my R Markdown and now Quartal reports. And Reactable.extras has a lot of great features that if you're a Shiny developer, you will definitely want to pay attention to if you've tried to do similar things with the DT package in the past, such as embedding custom inputs as cells in the table itself, like maybe having an action button if you want for a particular row, or a drop-down, or a text input. Reactable.extras gives you an easy way to build those custom inputs inside your Reactable table, as well as tackling a big issue that can happen with voluminous data, just as we touched on in Josiah's post, of server-side processing of the table content, so that you're not trying to load all the data at once in that table. Even if you're only going to show like the first 10 or 20 rows, it'll load dynamically using the server as the processing as you need it. So that can be a huge gain for efficiency. And as I mentioned, custom input, custom styling throughout. I can't wait to play with this more, because Reactable is literally, I cannot make a Shiny app without Reactable anymore. So being able to supercharge it with more Shiny stuff, I'm here for it. So again, congrats to the Absalon team on that release.
You and me both, Eric. And I'm excited for that server-side processing. I know that's one thing that we've been waiting for a while. It's been available in some of the other packages. I think maybe DT has the capability to do that, or maybe some other packages that I can't think of at the moment. I'm almost a little surprised that, and maybe hopeful that that logic actually gets merged into the reactable package itself, but we'll see if that happens. But very, very exciting developments as well. And congrats to the Absalon team for getting that package on CRAN. I'm going to double down on Absalon this week because there's a blog post that I cannot resist from Peter Storyenko. It's called "Folks, Come On, Use Parquet." It is a plea for folks to move from using CSV files to Parquet, talking about all of the different advantages between storage efficiency, between type safety, especially because Parquet files also have the data types for each column as part of the file. Columnar storage, it's a lot easier to work with and just super efficient. I know that probably it's maybe scary or cutting edge to some non-technical folks out there, but it will improve sort of every aspect, in my opinion, of any data science project that you're working on, from performance to safety around types to storage. And it's sort of a no-brainer. It does remind me of a terrible blog post somebody wrote on the Posit blog a year or two ago around working with Shiny and Arrow. But I think this is a great improvement upon that one.
Oh, no, don't.
Shameless plug.
Shameless plug, but also well deserved. But yeah, this is terrific to see too. And I'm playing with more Arrow and Parquet all the time now on my other projects. So I have you to thank for getting me hooked onto that already, Mike, with that great article. And it's great to see Absalon with this call to action even further.
Absolutely.
And we love to hear from you in the audience for your R adventures or new ways you're leveraging R in the world of data science and your adventures there. And one of the ways you can give us a feedback is send us a fun little boost on those new podcast apps. And I've been delinquent. We have a new boost to share with all of you. It is a row of ducks, which means it is 2,222 sats from Kyron of the Mere Mortals podcast, where he says, "Thanks for the shout out, guys. I know next to nothing about R, but enthusiasm and passion is infectious, and I enjoy listening anyway. So here's some value for perking me up." Thank you, Kyron. That was a great little encouragement for us. And check out Kyron's Mere Mortals podcast as well as his Value for Value podcast if you want a great deep dive into a lot of the concepts that I'm trying to adopt for this very show and maybe some future shows down the road. So thank you again, Kyron, for that fun boostergram. And if you want to do what Kyron did, you have a couple ways. Like I said, grab yourself one of those new podcast apps like Podverse, Fountain, Cast-O-Matic, Podfans. There's a whole bunch out there, and we'll have a link to where you can find all those apps at newpodcastapps.com. Also, if you want to keep your old podcast app, hey, we don't judge. I know how it goes. Just like some of my R coding habits, it's hard to change sometimes. So you can boost us directly on the podcast index page, or we'll have linked to in the show notes as well. You connect that with Alby or another technology. It's very easy to get up and running quickly. But also, you can get in touch with us with our contact page directly in the episode show notes. And also, we love to hear from you on our various social media adventures. I am starting to toot a little more on Mastodon. I am at our podcast at podcastindex.social. You can also find me on LinkedIn with cross posts of this and other random musings from time to time. And we may have another episode before this, but in case we don't, I'll just cover my bases here. I'm actually going to be part of a fun webinar on December 11th where we talk about some of the gains that we've had with Shiny in the clinical submission space in a joint webinar with some of my colleagues in pharma as well as FDA. So definitely check that out if you're in this space and want to see what we're up to on the Shiny submission space. But Mike, where can the listeners find you?
That's exciting, Eric. I can't wait to tune into that. Probably maybe one of the best places to find me would be on LinkedIn. You can just search Ketchbrook Analytics and find me, KETCHBROOK, or on Mastodon at Mike_Thomas at fostodon.org.
Very nice. And also a little mini shout out to JD Ryan, one of our fun data science hangout piece, because I am now the proud owner. Mike will be able to see this, but you listeners can't, of a new Our Cats hoodie based from JD's online Etsy shop. So little plug, maybe somewhat advertising nonetheless. I'm not getting any kickback from JD, don't worry. But I love this. I love this apparel, and I love to combine two things I love: cats and R in one place. Yeah. She has my money now for it. So
if anybody's looking for a Christmas present or a holiday present for their favorite R developer, definitely check out JD Ryan's Etsy store there. It's awesome.
Very good. Very good. I can never have enough R apparel. So now at the next year's PosiConf, I have good fortune to go. I'll be rocking this over there too. So, well, I think I've rocked this podcast with rants enough. So I think we're going to close up shop here. But thanks so much for joining us from wherever you are. And hopefully we'll be back with another edition of our weekly highlights next week.